Hello and welcome back to another IB Math Speedrun with me, Vince. We're going to be continuing our exploration of real-world applications for calculus and differentiation, so let's jump right in. So the second real-world application is actually a continuation onto the first, and it is profit and loss because, a lot of the times industries want to maximize their profit, and so we'll be using calculus to calculate what's the maximum profit they can achieve, and so what level of output they need to hit or something like that. So yeah, let's start. So I will be doing questions, the odd ones. So let's jump right in. So our first question, these are all long word questions. Company manufactures scientific calculators. The cost of manufacturing one calculator in a batch of size X, it can be modeled by the function cost of X is equal to 0.01 X cubed minus 10X plus 150. Find the batch size where the cost per calculator is minimized. Okay. So this is, I guess, pretty straightforward. With this, we just need to get the derivative and find the minimum. So we get we already have the equation over here, so I'm not going to rewrite it, so we're just going to jump straight in. So we have dy over dx is equal to 0.03 x squared minus 10. Find the minimum of this. Well, we have x squared is equal to 10 over 0.03. So x is equal to 10 divided by 0.3, square root that. So it's around 18.2 calculators, or I think the batch size should be, 18 calculators, more or less. So this is the correct answer. Okay, on to the next one. We have the question, the production costs of X USB flash drives made by a company can be modeled by the function cost of X is equal to 500 plus 3X. The projected selling price is modeled by the projected selling price is equal to 7 minus 0.002X. Okay. The projected revenues can therefore be modeled by the function lag. Our revenue of X is equal to X times 7 minus 0.002X, because it's selling price times number quantity sold. So we need to find the domain of the price function. B, find the break-even points of the production of the flash drives. C, state the levels at where that must be met for the company to make a profit. And D, find the maximum profit that the company can make from sales of flash drives. Okay, this is a lot. Okay, domain of the price function. So some obvious assumptions is that the range of the price function should never be less than 0, and also the domain should always be greater than 0 itself, because you're not going to sell negative calculators. So I would say x for the domain is x is part of I guess the natural numbers, and x is greater than 0 but less than, well, when will this price occur to be 0? 7 over 0.002, so x is less than 3,500. Because at that point, the price would be 0. Actually, we could probably include these guys, to be honest. Yeah. So, find the break-even points of the projection of the flash drive. Break-even points are when total revenue is equal to total cost. So you have no profit, but you're also not making any losses. So total cost is 500 plus 3x. And we need to make this equal to total revenue, which is 7x minus 0.002x squared. So we get our break-even point is 0.002 x squared minus 4x plus 500 equal to 0. So this should be equal, let's plug it in. So we have 4 plus or minus the square root of 500 plus 16 minus 500 times 0.002. Which is equal to actually 4. 16 minus 4 times 500 from 0.002. Yeah, so it's equal to 4. All over 0.002. So this is 4 plus or minus 16 minus 4 is 12, so it's 2 root 3, all over 0.002. So there's actually 2 break-even points, apparently. So probably if we're overproducing, we'll hit a boundary where we shouldn't be producing anymore. If we want to expand this, would be 4 times 0.002, 4 divided by 0.002. So we have 2,000 plus or minus 1,000 square root 3. Those are our break-even points. So next we need to state the levels that must be met for the company to make a profit. Well, it's simply going to be the parts in between the break-even points. So 2,000 minus 1,000 square root 3 is less than x is less than 2,000 plus 1,000 square root 3. So that one was pretty simple. And finally, actually I'm looking at the book right now, and it says that what we should be getting is actually, because I forgot to multiply this by 2. Sorry, yeah, so I made a slight mistake. This should be 0.004 since we need to multiply by 2, so this should only be 1,500. Yeah, because I was wondering, this second one is nearly out of the domain. So anyways, we have 1,000 plus or minus 500 and so over here we have 1,000 minus 500 square root 3 and then we have 1,000 here plus 500 root 3. Okay, and so finally we need to find the maximum profit that the company can make from sales of flash drives. So we need to maximize this function over here. So to do that, we will get the derivative. So dy over dx is equal to 0.004 x minus 4. So the maximum profit will be when x is equal to 1,000, I believe. And so let's find what the value is. And so the maximum profit will be when we plug in 1,000 here. So this will be 0.002 times 1,000 squared minus 4 times 1,000 plus 500. So this is minus 4,000 plus 500, so minus 3,500. So this is going to be 2 times 1,000, so is it 2 or 20? Yeah, I do have a sign the wrong way around. It should be negative, positive, negative. Which doesn't really change the final outcome. It's still at 1,000 units. We should be producing 4,000 1,000 times 7 minus 0.02 times 1,000. So 7 minus 2, which is 5. What units is this in? Because, okay, I think, yeah, no, so we get a maximum at, okay, the book's just confusing me because they've given it in some weird units that I don't understand, so I'm going to have to skip this last part of the question. But the maximum profit should simply be 4,000 minus 2,000 minus 500, like 1,500, something like that. So yeah, it should be like 1,500. Okay, so moving on to the last question. I think it's the last question, yeah. So we have a gardener plans to enclose 3 sides of a 1,000 meter squared rectangular plot of land with shrubs. The shrubs cost 15 per meter, and the fencing for the 4th side costs 3 per meter. Determine the approximate dimensions of the plot that would minimize the costs for creating the plot. So we need to enclose 1,000 meters of land. The shrubs cost 15 per meter, and the fencing for the 4th side costs 3 per meter. So let's say the width of this plot is x, and the height of this plot, or like the length of this plot, is 1,000 over x. So let's also say that the 4th side will be with the length of the plot. So the total costing would be 2 times x times 15 plus so more or less actually it's just 30x. It's lagging. 30x plus, and then 15 plus 3 is 18. 18 times 1,000 over x. So this function, well, let's get the derivative. And we get 30 plus 18, what is this? Oh, sorry, minus 18. 8,000. Yeah, minus 18,000 x to the negative 2. So we need to find the maximum. In this case, this would be when 30x squared is equal to 18,000. So x squared is equal to 6,000. So x is roughly equal to where is it? Square root 6,000. So we have oh, sorry, I think it's square root 600. Yeah, my bad. So x is equal to 24.5 meters. So the length, the width will be equal to 24.5. And therefore the height should be 1,000 over this. So it should be something like 40.8. And the last thing we want to do is to calculate the total cost. And the total cost, let's plug 24.5 back into this original costing function. This will be equal to 30 times 24.5 plus 18 times 1,000 over that, plus 18,000 over 24.5. So this is equal to 30 times 24.5 plus 18,000 divided by 24.5. So the total cost should be around 1,470 euros by my calculations. So yeah, that was it. That was all for the speedrun, and I hope you learned some more about modeling and using calculus in modeling, and I hope to see you in the next one.